Alright, it's John here again, and we're going to work on Project Euler, problem number 8. We're going to find the largest product in a series. So it says the four adjacent digits in the 100-digit number that have the greatest product are 9989 is equal to 5832. So what we need to do is take this whole input and turn it into individual numbers. So let's start with just copying and pasting the whole thing, and we'll just define this as a string. Let's just call it input, and we just need some quotes here. Okay, so we have our input here. Let's evaluate that and see what it looks like in the REPL. Okay, looks like a big string. So now what we need to do is we need to break that string into characters that we can turn into one-digit integers. So if we let's just map identity over the input, because a string in Clojure is also a sequence. So we'll see when we do that down at the bottom, we have everything as single characters with some new lines in between. So let's just filter out the new lines. Filter. And we'll say not equal to the character new line. Let's try that out. Now when we run it, same thing except all the new lines are gone. So now we have just character. We just have characters in our sequence. So now we want to turn those into the number that's there. So let's do if we just run the int function, that would seem like the way to do it, right? But unfortunately, well, if we map the int function across our data, then we get not the numeric not the integer that corresponds to the digit. We get the actual ASCII code for that character, and that's not what we want. So what we want to do really is we want to read the string. We want to map the read string function across these. And there we see that we can't convert a character. We can't convert a character to a string. So we needed to help out Clojure with that. So what we need to do is do read string, and then also we need to put our character into a string. So that way we can take that character, turn it into a string, and then parse the string to get the integer out, the single digit integer. So there we go. Now we've got that whole big block as a sequence of integers that we can work with. So let's just define that as numbers. So now we have our numbers. Whoops. Define them as our numbers. Okay. So I think the strategy that we want to do is we're basically going to start at the beginning and then just work our way, multiplying the current and the next numbers together. And then to not worry about the in the terminating conditions, right? If we have to worry about, where to stop, we'll just pad ones onto the end of this whole thing so that we won't have to worry about kind of running out of numbers to multiply at the end. So let's go ahead and write our function. It's series product. Okay, and we're going to take in a sequence, and then we also want the n number of adjacent values to multiply together. So let's start by padding our sequence. Padded, and what we want to do is we want to concatenate the sequence, and we want to repeat n times 1. So now we'll get n, so if we're doing 4, then we're going to get 4 ones on the end of this. So that way we'll have that kind of buffered with 1, so we don't have to worry about index overflows and things like that. And then the other thing we want to do here for our convenience is this concat is going to return a list, and what we really want is a vector so that we can do efficient index lookups. So let's do into a vector here. Alright, so let's just test it out, make sure everything's working as we expect. So let's do padded nums, and our n for our test case is 4. Oops, not padded, sorry. Series prod. Okay, so that gives us down here our whole vector, and if we scroll all the way to the end, then we have also four ones at the end, and it's a vector. So far things are looking good. So now we basically want to iterate through our list. So we're going to say for I in the range up to n. So that's going to give us 0 through n minus 1. Then we what we want to do is grab the indexes for the next n numbers. So let's do let I'll just call it j. I'll call it the j's. It's going to be equal to the range of I up to I plus n. Okay, so now we have for each I, then we have n j's, which start with I and they go up to I plus n. Okay, so now that we have that, then basically what we want to do is we want to look up the value in padded at the index j. So that is nth of padded and then some index. Okay, and we're going to map this function across the j's. So that's going to give us the jth value at each of those. And then we want to reduce with multiplication across those. And that's basically it. So let's evaluate that. Missed my anonymous function macro. There we go. Let's try that again. Okay. We did not do this correctly, obviously. What we did wrong was we used range in. What we wanted was count of our sequence. Let's try that again. Okay, so now we have a bunch of answers, and if we sort those answers, let's do that different. We have our answers, and let's take those and then sort them, and then take the last of those. Great, now we have 5832, which is the correct answer. So now we just go find the 13 adjacent digits, and we get this big number, and let us try to solve it. So I'll just copy paste again. Alright, that's the right answer. Thank you for watching.